So hi everyone. In this video, we are going to discuss about design thinking based how to control stability in control system. Normally, the design thinking is a human-centered approach for solving the complex problems. In this video, we are going to discuss about how to solve the problems in control systems. Especially for the stability system, we are having a lot of system for analyzing all those problems. Normally, we are having a lot of techniques such as Bode plot, polar plots, and the Nyquist plot, Routh Criterion techniques, and Routh Locus techniques. So these are all techniques which is used to identify the stability of the system. Normally, these topics are very useful to analyze the effect of stable systems. So let me discuss how this system has been analyzed and enabled in the design thinking process.
The first stage of the design thinking is empathize. In this stage, the main thing is to understand the purpose of the system, the main purpose from the user's perspective, and it affects the instability of the performance of the system by the user's perspective. Mostly the users are engineers, system operators, and the end users.
While getting to the defined part, in this stage, we focus on clearly understanding the stability for our system. Is it about quick response, minimal overshoot, or maintaining our output within bounds? We then look at the positive cases of instability. Maybe the controller is not tuned properly. So, the sensors have delays, and the system behaves differently. The system behaves differently in certain conditions. The goal is to turn these insights into a clear problem statement. For example, the robot becomes unstable or uneven due to the poor adaptation to changes.
Okay, coming to the third part of design thinking, I did. In this stage, we brainstormed the right methods and techniques to get the system stability analysis. Coming to the mathematical or analytical methods, from the Routh Locus method, where
Based on the poles.
Based on the pole movements with the varying gains, it is used in a controller gain tuning also. And the next is the Hurwitz Criterion, in which the stability of the system is obtained from the equations. Like it is also used for quick stability check also.
Based on positive and negative.
Positive and negative. And moving to the Bode plot, where the phase margins and the frequency responses are analyzed, and also the stability margins are analyzed in the frequency domains. And the polar plot, we can see the phase and magnitude which varying with frequency in the circular view. And finally, the pole zero mapping, it makes us to understand the dynamic characters of the system, as it shows the location of the poles and the zeros directly, so we can determine the system's behavior according to that. And the simulations part, we can use Simulink or other tools to simulate.
MATLAB, we are using
MATLAB, and we can test that in the sandbox to observe the real-time response of the system. And coming to the heuristic techniques, we can try gain tuning and tweaking and fuzzy logics, etc. We can also use AI adapted data-driven techniques also.
Yeah, coming to a fourth step of our design thinking, it's a prototype. It involves 3 steps like model development, stability analysis, and control tuning. As we said, the polar plot and etc. are used for this process. Model development is we should develop a mathematical representation of a project, like a transfer equation or etc. As coming to our next step, It was a stability analysis. By controlling or changing our loads and etc. By changing it, we can stabilize the simulation of our project. Next step is control tuning. By changing a more number of control tuning, we can check the correct stability of our project. For example, if we are operating a robotic arm, we should stimulate in a computer, then we should tune it into the different possibilities as we can attain a stability state.
So the last and the final step, important step in the design thinking is the testing. So while we delve into the testing part, we need to validate the system, whether the system is functioning thoroughly or whether adapts the system to the external environment. So basically we test the prototype in the 3 different methods. First one is the simulation testing. So we conduct the closed loop simulations to observe a overshoot and the settling time and the steady state errors. And the second method in testing is the real world testing, where we apply our practically tested products into the real world scenarios to analyze the robot experience. And third is the stakeholder feedback, because when the user gets their required expectations, we can analyze whether the product is able to set in the user experiences, and we can analyze it through that. So finally, we are validating the system and refining the system through the user's expectations. This is all about the testing. And coming to the conclusion part, design thinking basically complements the traditional linear control systems by implementing user-focused and innovative practical applications and etc., which helps engineers not only analyze the mathematical stability but also understand the product's usability and adaptability in the environment. So this is all about the by empathizing the problems and redefining the solutions, problem statements, and diving into the various solutions and prototyping and rigorously testing, we can say that engineers can even better develop the systems through the linear control systems in dynamic, which is like a very crucial in the areas like robotics, drone, and etc. Thank you.
Thank you.